Hello, beautiful people. We're going to go ahead and go over notes lesson 2.1 to 2.3. So we're now in unit 2. We're going to be learning several ways for writing and comparing ratios, learn methods for setting up and solving proportions, learn how to use dimensional analysis to do unit conversions. So to start off, a ratio is a comparison of two quantities. Ratios can compare part to whole or part to part. So our first example is going to be writing ratios. This comes from lesson 2.1. So in a class of 30 students, 6 students are absent. We want to find the ratio of the number of students absent to class size. So the number of students absent is going to come first, and then class size will come second. So we can see that we have 3 ways to write a ratio. We can do 6 to 30. We can also write it like this. It's the same way, 6 to 30. Or the most common is in fraction form, which is 6 to 30 as well. Okay, so again, you can write ratios 3 different ways. And if, let's say, you like writing it as this way, you can change it to this way. You can change it to this way. Like, it is the same thing. It's just 3 different ways to write them. So you'll see in this notes and our weekly assignment that they're written all different types of ways, those 3 ways. But like I said, the most common is going to be in fraction form. And 6 over 30 is equivalent to 1/5, right? If we divide top and bottom by 6, we're simplifying. Those are equivalent. So if you saw 1 to 5, it's a 1 to 5 ratio. 6 to 30 is a 1 to 5 ratio. So those are equivalent. They're the same thing. Okay, so Carly has 2 cats, 3 dogs, and a bird as pets. What is the ratio of number of cats to the total number of pets she has? So we're going to go the part to the whole. So this is an example of a part to whole ratio problem. Okay, so we're going to set it up. So the part that we want is the number of cats. Well, how many cats does she have? She has 2 total. And then the total number of pets. Well, she has 2 cats, 3 dogs, and 1 bird. So that's 2 plus 3 plus 1, which is 6. So her ratio is going to be 2 to 6. Well, we need to simplify that because our answer 2 to 6 is not there. So if we simplify this, this will come out to 1 over 3. And we simplified by dividing top and bottom by 2. So she has a 1 to 3 ratio of cats per pet. So that's basically saying for every 3 pets, she has 1 cat. All right, so our answer will be B. A cookie recipe uses 1/4 cup of flour and 1/8 cup of oil. What is the ratio of flour to oil in the recipe? Well, I'm going to kind of go off to the side. So if I have 1/4 to 1/8, okay, you can also set it up like this, 1/4 to 1/8, or 1/4 of 1/8, right? This looks messy, and so I'm going to stick with these 2 ways. I'm actually going to go ahead and do this one right here. I'm going to go ahead and erase that. So if I'm going to do it with that, let me go ahead and put it up here. So I have 1/4 to 1/8. Well, I can see that all of my answers here are kind of simplified. And they're simplified to whole numbers. So what I'm going to do is I'm going to multiply by the largest denominator on both sides. So in this case, it's going to be 8. So I'm going to multiply by 8 on both sides. And that's going to cancel that out to 1. And then 8 times 1 is 8. 8 divided by 4 is 2. So this is 2 to 1. It is a 2 to 1 ratio. So for every 2 cups of flour, you're going to add in a cup of oil. Okay. And if you even looked at the denominators here, you can see that 1/4 is twice of 1/8. So like 1/8 twice is going to be 1/4. That's cut in half, right? Because it's if you cut 1/4 in half, you're going to have 1/8. Okay. Example 2. So comparing ratios. Sam and Charles are practicing free throws. Sam made 16 free throws out of 20. Charles made 21 free throws out of 30. Based on the information, who is the better free throw shooter? Well, if you know basketball, then you know we usually break it down. It'll say like, oh, LeBron James had a 98 shooting average or whatever it is, right? That's probably super, super high and inaccurate, but I'm just giving you an example. If we first look at our ratios, right, let's go ahead and set them up. So for Sam, he was 16 to 20. And then Charles was 21 to 30. Well, this is actually hard to compare because when you're comparing, you really want to look at the denominators. But since our denominators are different, like it is hard to see which one is actually better. So let's go ahead and make a table. So let me make sure I'm not on the highlighter. So this will be for Sam, and then we'll have this for Charles. So let's say this is the shots made, and then out of the total. And then again, the shots made out of the total. So the shots made for Sam was 16. The total was 20. For Charles, it was 21 out of 30. Okay. I want to see how I can manipulate these numbers to have the same denominator. Okay, so I know that 20 and 30, I can, let's say I want this to be 10. Okay, I want the denominators to be 10. Well, what do I need to do to 20 to get it to 10? Well, I need to divide by 2. But whatever you do to one side, you have to do to the other. So I have to also divide by 2. So what would be 16 divided by 2? That would be 8. And then if I look here, well, what did I do to 30 to get to 10? Well, I'm going to divide by 3. Whatever you do to one side, you need to do the other. So we divide by 3 again. So 21 divided by 3 is 7. So now that we have the same denominator, we can look at our ratio here and say, okay, who is actually the better free throw shooter out of 10 shots? Who is making more? Well, 8 to 10 is better than 7 out of 10. So Sam is the better free throw shooter. And so if we know this is 8 to 10, and we know this is 7 to 10, right? We can see that that's greater. This is going to be written, that will be 0.80 as a decimal. This would be 0.70. So based on these shots, he's making 70% of his shots, and he is making 80% of his shots. Okay, so we went from a fraction to a decimal to a percent. Okay, so Sam is the better shooter, to answer that. Okay, and usually I would put in a complete sentence, but I ran out of room. But that's what we're going to be doing is some tables like that. It really helps us see how these break down. Okay, so Jenna puts in 5 packets of sugar in her 16-ounce cup of coffee. Sophie puts in 4 packets in her 12-ounce cup of coffee. Which cup of coffee is sweeter? Justify your answer with calculations or ratio table. These are called ratio tables. So let's go ahead and do that again. I'm going to do it in different colors this time. So Jenna will be this table. So we have the amount of sugar per coffee. And Sophie will be the green table. So the amount of sugar per coffee again. So to start off, Jenna's going to put 5 packets of sugar for a 16-ounce cup. And and Sophie's going to do 4 packets of sugar in her 12-ounce cup. And again, it is really hard to compare these fractions just by looking at them. So if we do this, we're going to do the same thing. Okay. So looking at 16 and 12, maybe 16 and 12 is a little bit hard to find what they're what we can make the ratio where they both are the same, right? They're multiple. Well, 5 and 4, I can do 5 and 4. I know that if I can get 5 and 4 to both be 20. Okay. So what times 4 gives me 20? Oh, well, 5 times 4. Whatever you do to one side, you have to do to the other. So 12 times 5 is 60. Okay, well, then 5 times 4 gives me 20. So whatever I do to one side, I have to do to the other. So 16 times 4 is 48. I want you to take a minute. I want you to look at this, what you know about fractions and denominators and everything like that. This is what I'm going to check from you guys tomorrow. When you guys show me your notes, I want you to tell me who's it sweeter based off of those fractions right there. I want you to compare them. Okay? Is Jenna's going to be sweeter or is Sophie's going to be sweeter? Now, the numerators are the same, so you know they both have the same packets of sugar in there. But the denominator, okay? So think about what we know about denominators, and the sizes and things like that. I want to check this one tomorrow in class, so I want you to have an answer, okay? All right, so a proportion is an equation in which two ratios are set to equal each other. Examples of proportions would be 4/8 is equal to 1/2, right? It's just broken down. 2/3 is equal to 6/9. 81/1/8 is equal to 3/4. What do we notice about the cross product? Okay, the cross product is when we cross multiply, right? 4 times 2 is 8. 8 times 1 is 8. 2 times 9 is 18. 6 times 3 is 18. 81 times 4 is going to be, oh my god, 364, I believe. That sounds really wrong, actually. 1 second, I'm doing the math in my head. 244. And then 108. Actually, why do I need to do it in my head? Because it's probably wrong. 81 times 4. 324. I think I had said that already. And then 108 times 3 is 324. So what do we notice about the cross product? They are equal. Okay, so then A over B, the ratio, is equal to C over D. We can say that A times D is going to be equal to C times B. That's exactly what we did right here on these two little tops. Imagine this is A, this is B, this is C, this is D. A times D is going to be equal to C times B. All right, solving the proportions. So now we're talking about lesson 2.2. There's a couple ways to solve proportions. We're going to do one way for each of them. Okay, first one that we know is the cross product. So 6x is equal to 12 times 5. Okay, you could have simplified 12 times 5 to 60, but I want to show you guys a way that you can actually do it and simplify and not blow up the problem, make it a lot simpler for yourself. So if I divide by 6, I want to divide the 6 right there by the 12. Because I know that 12 divided by 6 is 2. So what I have is 2 times 5. So x is just equal to 10. And if you would have done 6x is equal to 60, you still would have gotten that x is equal to 10. But here we just simplified it. Your second method, okay, is you're going to multiply both sides by the denominator where the variable is at. So the denominator on that side is 12. So we're going to multiply both sides by 12. That's going to make that 1. So then we're just left with x is equal to 12 times 3, which is 36. 36 divided by 2, which is 18. Okay, but you could have also kind of looked at that and said, okay, well, 12 divided by 2, that's 6. So now I have 3 times 6 is 18. Okay, now your third way is to look at your ratio and see how it is that 5/8 is equal to 25 over x. Well, look here. What times 5? 5 times what gives us 25? Well, 5 times 5 gives us 25. And again, whatever you do to the top, you have to do to the bottom. So we're going to do 8 times 5, and 8 times 5 is just 40. So x is equal to 40. Okay, so those are the 3 different ways. We'll practice that on our weekly assignment this week, but those are 3 different ways to solve proportions. Okay. Nick drinks 8 ounces of milk for every 5 cookies he eats. If he eats 20 cookies, how many ounces of milk does he drink? So there are several ways to set up and solve the problem. We can use the ratio table, and that's exactly what I'm going to do. I'm going to set up a ratio table. So if we know we have milk and we have cookies, we know that he drinks 8 ounces of milk for every 5 cookies. And if he eats 20 cookies, how many ounces did you drink? So we're trying to find this right here. So, well, what do I do to 5 to get 20? I multiply by 4. So what do we do to 8? We're going to do the same thing. We're going to multiply by 4 to get our missing answer. And 8 times 4 is going to be 32. So our answer is, how many ounces of milk does he drink? He drinks 32 ounces. for 20 cookies. Okay. Raj answered 75% of the questions correctly on a test. If he got 27 correct answers, how many questions were on the test? Let's set up another table. So here we have our percent, and there's the amount. Okay, so we know he had 75% correct, and 75% correct was the 27 correct answers. It tells us right there, 75% of the questions correctly, he got 27 correct. So if I divide this by 3 to get the other 25%, right? Because 75 plus 25 is 100. Then that means I have to divide this side by 3. So that's 9. Well, that means 75% was 27 questions. That means 9 of them were wrong because that's 25%. So if he only got 25%, he would have only answered 9 questions right. But he got 75%. So he answered 27 correct. Now, to get how many questions in total? Well, what times 25 gives me 100%? Well, 25 times 4. So whatever you do to one side, you have to do to the other. So 9 times 4 is 36. So there was 36 questions on the test. And again, there is multiple ways to go about answering these questions. We'll talk more about them in class, but I do want to show you the percent table, the ratio tables, because they do help. All right, now we're going to go ahead and talk about dimensional analysis. So here we have the conversions over here for cups, inches, things like that. So Sunny has just reached the 5-gallon club for blood donation. How many cups is this? So we're going from gallon all the way down to cups. So we're starting with 5 gallons. Okay. 5 gallons, we first have to break it down to quarts. So 1 gallon is equal to 4 quarts. Okay. So just follow me. Then we have to break down quarts into pints. So 1 quart is equal to 2 pints. And I'm getting all this information off the table over here to the side. Now we have to break down the pint to equal the cups, which is our last thing. So 1 pint is equal to 2 cups. Now I'm probably like, why are we like separating all of this like this? So what you're going to do is every single unit you're able to cross off. That's how you have to do it until you get to the unit that you want. So we have a gallon per gallon, quarts per quart, pints per pint, and we're left with cups. So we know our answer is going to be in cups. Now what you're going to do is just go ahead and multiply all the way through. So 5 times 4 is 20. 20 times 2 is 40. 40 times 2 is 80, and it's all over 1. So it is 80 cups. 5 gallons is equal to 80 cups. All right. Jenny bought 4.5 yards of fabric to make curtains. If she wants the length of the curtains to be 108 inches, does she have enough fabric? Justify with calculations. So again, we're going to go from yards all the way down to inches. So there's 3 feet in 1 yard, and 1 foot is 12 inches. So we're starting with 4.5 yards. We're going to multiply that conversion of 3 feet per 1 yard. Okay, and then 1 yard is equal to 12 inches. Oops, sorry. My bad, put it in the wrong spot. So 12 inches is equal to 1 foot. Okay, so we're going to cross yards off with yards, and it has to be, you see how one's on the top, one's on the bottom? That's how you have to have it. Feet with feet. So then I'm just going to go ahead and multiply. 1 second, please. 4.5 times 3. And then we get 13.5, and then 13.5 times 12, that's going to give us 162 inches. All right, I want you guys to go and see if you guys can go ahead and solve this one by yourself. So set it up. I'm going to just tell you right now that 1 kilometer is worth 1,000 meters. So start there, because you have 880 kilometers per hour, and you